Okay, good morning, everyone. So today we're going to finish the script that we were developing already, and then we're going to start and finish another one that's going to be that's going to include geospatial data. And hopefully we're going to have time to talk about the mini project. So we're going to be introducing that to you today and assigning you your projects and getting that started. Okay, so for today's class, if you don't have yet your RStudio open for the project that we were working with, you can see here on my screen, I'm at the main level of the course. I'm going to go on to 02 NASS, which is our project, and I'm going to launch the 02 NASS rproj to launch this project. So please go ahead and do that as well. So for me, already launched with the script open. So you can see where we stopped. We basically stopped at this chunk here where we were doing the table with lowest production. So if like on my side here, if you don't see the objects and everything else on your environment, you can go ahead and just hit a run all above, which is this button right here, and that should run all the chunks above this one. And if you did not leave any lingering like code errors above, it should run fine. But I guess the main point is that you have the soy.w available because that's what we're using. So if soy.w is appearing on your environment, then you're good to go. I'm just gonna give a moment here for everyone to get to this point. If for some reason you couldn't get to this point, you may speak up and we can try to address that. Okay, so I don't hear anything. If you do have issues, let me know. We can address them, but I'm gonna keep going here. Okay, so the last thing that we did here was to look at the table with the lowest production county, right? So we found out that the lowest production happened on County Glasscock in 1959. And now if you just go to the next chunk, here's what I want to do in this next chunk. And I really want you to follow like the train of thought because you're gonna have to be doing this for your mini projects. So if I ask you to plot, so if I say plot, it means that we're gonna make a graph. If I don't say plot, it mostly means that we're doing a table or some sort of table, like what we've been doing up until now. So if I want to plot the average county production for each year, right? So we don't have that data yet. Let me just print soy.w. So soy.w has like almost 6,000 rows, which is basically showing us, all the data that we have up until this point. But if I want to show the average county production for each year, so think of it that I want to plot where for each year, instead of having 159 potential values, one for each county, I only have one for each year, right? So, and if I'm saying that I want the average, you should be already thinking that we need the combo group by summarize. So if we have to group by, so let's just start here, right? So let's add a pipe and let's add a group by. So what is the variable that we should be grouping by at this level? Anyone can help me here. Let me ask Sarah. Yes.
By year.
Yes, by year. That's perfect. And I just wanted to make you all think about this because, we want the average county production per year. So that can be a little bit confusing. You may have thought that we would group by county, but no, right? We want to average over county. So we group by year. So thanks, Sarah. Appreciate the help. Okay, so we group by year. And then we add a pipe, and now we're going to use that combo group by summarize. So we call summarize, and I want to call this mean prod, like that. say equal, and then we're gonna use the function mean, right? Because that's what we're trying to get here. And we want to get the mean of the production in million bushels, okay? So we get the mean of that. And if you remember, this column has some NAs, like we're seeing right there. And from the first class, if you remember, if we have NAs, it will return NAs. So we have to call this argument called na.rm for NA removed and say true. So we removes that first. So if you do this, and if you run it, now you should have 63 data rows where you have a mean production for each year, right? So this is kind of like on the data wrangling side, what we needed to do to address this question. However, I'm asking to create a plot of that. So you can just go ahead and add a pipe here and hit return, and we can just plug this resulting data frame right into ggplot. So we can just add ggplot now. And since the data is already coming from, all this is the data coming into ggplot, we don't have to say data equals something, but we still have to specify the aesthetics. So we have to say use the AES function to do that. If we want to plot, normally year or time goes on the x-axis, so we say x equals year, comma, y equals mean production, which is what we created above. So if you run this, and if you remember, this just creates an empty canvas for us with the variables and the ranges of the values, but not yet there is no geometry showing the data, right? So we could use a geom point, but I want to show you here, geom line is actually going to be a nicer case. So if you want to, and also here's something to call your attention. So when we're doing data wrangling and connecting things, we're using the pipe. But once that pipe, or once this data gets into ggplot, we do not use the pipe inside ggplot, we use plus, right? So add a plus sign right there, and let's just use geom_line. So if we run this, this is what we get, right? So we see that when we do the average, so this is not the total production, right? This is the average production at the county level for each year. We see that around, I don't know, maybe 1980s, we had a peak of production at the county level in Georgia, and that went down, went up a little bit again around 2010. So this would be like, so 2000, 2020, this would be 2010. And then it kind of stabilized with ups and downs after that.
Dr. Bastos.
Yes.
My graph doesn't exactly, and us in Tifton, it's missing some points, or like it just cuts off for about 1970 all the way to 1990. It's just there's nothing there.
Okay.
It's like they're missing years in the data.
Interesting. So that so is it for everyone in Tifton?
Yes, I get a warning up above the graph that says 2 rows containing missing values, and then in parentheses it says genome line.
Okay. So it may have something to do with the data wrangling steps. So for right now, let's just like if we can keep going, I think we can keep going, and then I can connect with you guys after class for us to see what's going on. Is that okay?
Yep, that's perfect.
Awesome. What is anyone else having the same issue? Like,
yeah, Dr. Bastos, someone at Athens also having these issues.
okay. So that
I was
yeah.
having that issue yesterday.
Yeah, I guess what we can do is perhaps we can connect like well, I guess let me ask you this. Was anyone able to get the graph to look like what mine looks like?
Yes, I can. I can see it.
Okay. So some people were able.
I didn't have. Oh, Dr. Bastos, everyone at Athens is now good.
Okay. Did you guys find a workaround that you could share?
The way I fixed mine was I realized that on my code I had the NARM, but I didn't have the equals T, and that was the difference.
Okay.
That's what
So
changed.
for those in Tifton, did you have the NA remove equals true at the mean level?
Yeah,
Yes, sir.
yeah, we have it all the way, but see, I'm going back and looking at every graph that we've done so far, I've got the exact same warning.
Okay.
Hang on, is that RA?
Okay, well, yeah, let's do this. Anyone that's having issues with that, so if your graph doesn't look like mine, we can connect afterwards and troubleshoot that. It's probably a difference in the data coming in. And we can work around that and see what's going on.
We got it.
We figured it out, Dr. Bezos. It's instead of an M, it's NA period RM. I thought you were saying N.
Oh yeah, it's na.rm. Yep.
Okay, all right, that's what.
Did that fix the graph?
It fixed it.
Yep.
Yes, sir.
Awesome. Cool. Good deal. All right. Well, thanks everyone for helping each other to troubleshoot this. Okay, so this is the plot that I was looking for, right? So the average for each year, so averaging across counties, right? Okay, so the next question I have for you is, what was the latest year reported in this data set? So what was the most recent year reported? And there are a few different ways of doing this. I want to show you one, and there's really no wrong or right or wrong answer. It's more like, as long as you can tell me what was the latest, that's what matters. But I want to show you one here so you can go ahead and use the pipe. There's this function called distinct, which is a pretty useful function that basically tells you all the distinct values within a column. So in this case here, we have almost 6,000 rows. A distinct function really helps us to, let's say, probably year 1980, or really whatever year is appearing many, many, many times in this data set. So if we do distinct and then we say year inside of it, it's going to come up with a list of all the distinct values. So even if a year appears more than once, is only returning once that value, right? So this is one way that we can see that. And just to make sure that it is arranged or it is sorted, let's go ahead and add another pipe and use the function arrange. If we do arrange year, it's going to be on a ascending order. So if we want that to be on a descending order, we just add the function desc or DESC and run it, and that will return on the descending order. And this kind of looks like what we had up until when we did the distinct by itself, but this also makes sure that if we're assuming that maybe it was not properly arranged by the level of the distinct, this way we make sure it is. Okay, so we see here that the latest year was 2021, right? So that was the last year reported in this data set. So the reason why I asked you why or what was the latest year is because now my next question to you is, what was the highest production in 2021? So if I want to know just 2021, what do you think that we could use here? Let me ask someone else. Maybe, let's see. Matt, do you have any thoughts here?
Maybe filter.
Yeah, that's exactly right. Thanks, Matt. So if we come here, we add a pipe and we do the filter. So what we want to do is year, right? Equal 2021. So that is our filter. So we only have 20 rows here. So only the 20 counties that had data reported in 2021. And if I want to know what was the highest production, we can use a very similar approach to what we did here on the arrange on the chunk above. So I can just come here at a pipe, then say arrange. So now we want to arrange the column production, right? Because that's what we're after, not the year anymore. So if we just do production million bushels, that's going to be on a ascending order again. And my question is, what's the highest? So to make this flip, we just use again the desc function like that and run it. So we see here that in 2021, County Brooks had the largest production, and that was 0.31 or 0.32 million bushels of soybeans in that year. All right, let's go to the next one. So if you're realizing here, we're just making a whole bunch of questions and using the data and data wrangling and plotting functions to answer, right?
I have one quick question, Dr. Bastos.
Yes.
Could you explain again the difference why we use equals for like the filter?
Yeah, so here on filter, we're basically using something that's called a Boolean operator. So a Boolean operator is something that you create relationships, especially when filtering, in this case, and that is used across math, but also in different programming languages. So if you just do one equal, I think it would give you an error. Yeah, it doesn't know what you're doing. So it has to be equal just because it is a Boolean operator, and that's how it is done. And if you recall, if we wanted all years except 2021, what we would have used the exclamation point equal, meaning different. So year different than 2021. So on other Boolean operators is like greater or greater than equal, lower than equal. So those are all the ones that we're going to be using normally in these types of operations. So it's just convention, I guess.
Thank you.
Yeah. All right. So next one, if you come to the next chunk here, I want to plot production over time for the highest producing county in 2021. So notice now I'm getting a little bit more specific of what type of data I want to show in this plot. So before we get to the plot, we first need to do some operations on the data to get the right data and then plot it. So, if we come on the chunk above, we notice that the county that produced the most in 2021 was Brooks. So if I want to plot data for that county only, I again would use filter, right? So now let's come here, add a pipe, use a filter function. Now the name of the column is county, right? So county equals, and then Brooks has to be all uppercase because that's how it is in the data. If it were just be uppercase and the rest lowercase, that's how we would say, right? Just because it has to match what's in the data. So we come here, we open and close parentheses and just, either paste or write Brooks. If you run that, you're going to see that now we have all county values are equal to Brooks, and then we have all the years for that county where that county reported data. So now that we have the data we needed, we're just going to plug that right into a ggplot call. So using the pipe and hit return, going to do ggplot, use the astatics function, so AES, going to say x equals year, comma, y equals prod underscore million bushels. And again, we're going to add a plus at the end and just use a geom underscore line to show that data. So if we run this, you're going to see now that, so Brooks was the largest producing county in 2021. So that's the data that you would have right there. But then we really see how the county evolved in production over time. So it seems like it had its, there are some gaps here, meaning that data probably wasn't reported for this county for those years. And we see that the best producing years of soybeans for Brooks County happened around 1980 as well. And then it reduced a lot in production and then increased again and fluctuated after 2005, perhaps. Any questions? All right, I'm going to keep going here. Okay, so basically what we're going to do next is pretty similar to what we did above, but now my question is the lowest production. Right, so I basically left you the code there because we had already pretty much done this code. It's just that before we use the desk here to do the from high to low, now we don't do desk because it then goes from low to high. So what was the lowest production in 2021? That was for County Bacon, and it was like 7,000 bushels, pretty much. Okay, so I had left you the code, most of the code there, I guess all the code there. So you have it all there. Now we're basically going to repeat what we just did above with the plots, because now my question is plot the production over time for the lowest producing county in 2021. So it's going to be the exact same code as we did above, except that now we're filtering a different county, right? So if we just add a pipe, we're going to say filter county equals bacon, and then plug that into a ggplot, where we inside the aesthetics function we say x equals year again, and y equals production. Let's again keep using the million bushels, and then just add a geom line after that. So it's a different pattern, right? I mean, as you would expect, because they're two different counties, but the county that produced the least in 2021 had its high producing years as well. So, you know, around 1980 through perhaps 1990s, 1995, perhaps had some good production around that time, and then it lowered again. So we see this different pattern as far as the highest producing county in 2021 versus the lowest producing county. Okay, so we basically did those plots separately for those two counties, right? What if now I actually wanted to do those plots, or have a plot, but have two different lines in the plot, where each line is for each one of those two counties that were highest and lowest producing in 2021? So basically, we have to filter. We're gonna again use the filter, but we have to filter both of those counties. And now I'm gonna introduce a concept that you have not seen yet when it comes to Boolean operators. So, you know, add the pipe there. Let's use filter again. So we could, you know, intuitively to me, if I were following and learning the sequence that we're doing, I would think that I could do something like equals, and then perhaps use the C function to say that I want county Brooks, comma, county Bacon. Again, Brooks is the highest producing, Bacon is the lowest producing. We want to have both of them together in the same plot, meaning we have to have both of them in the data set that comes into the plot. So, you know, this kind of makes sense to me that it should work. I don't think it does. Let's go ahead and try. You know what? It actually did work. That maybe there was a change. So never mind. So let's just, you know, I was gonna tell you something else because this did not used to work in the past. So I'm glad that now it works. It's just easier. Okay, so we basically filtered both of our counties. The data for, oh, let me just try something here and make sure that it gives the same result. Okay, so it actually didn't work. Sorry. So here's, I'm actually not sure what equals did here, but we did end up with 56 rows, and I'm not sure why. But the actual correct answer here was, instead of using, whenever you're filtering more than one value from the same column, instead of using equals, we use percent in percent. So please go ahead and change that, because this is what I was going to teach you, and then I was surprised when equals worked. But then I tried again using the in, and I noticed that it gives a different number of rows, which is probably the correct number of rows that we want to have. So please go ahead and do change the equals to in. And this is just that concept I was telling you about, is whenever you want to filter more than one value from the same column, you do specify those values using C, but instead of using equal, we say in. So basically, we're getting the counties Brooks and Bacon in the column county. It's kind of like flipped, but I hope you get the gist. So now we have the data that we needed. Let's just go ahead and add a pipe. Let's start a ggplot call again, because we want to plot it. Call the aesthetics function. We're going to say again, x equals year, comma, y equals prod in million bushels, comma. And now there's, well, let's just stop here, add the plus and add geom line to see what happens. So this is what happens. And really what's going on here is that for each county, there are like one data point on each year, And what ggplot is doing is basically connecting those 2 points across different counties. And that's why you see the like jigsaw type of pattern. And that's not what we want, right? So we do want to differentiate the points between different counties. So to do that, we come back here on the AES function right after the prod million bushels, add a comma, and say color equals county. So now if we do this, now we don't have the jigsaw pattern anymore, but we do have the 2 counties separately, right? And we have the legend here showing which one is which. So again, we see that Brooks was the highest producing in 2021. We do see that huge gap here in 2021. And we also see that on the years preceding that, Brooks was also producing more than Bacon County. They kind of produced similarly for a period here, but also early on, between 1960 and 80, Brooks was always outperforming Bacon County as far as how much soybeans was being produced. So again, the difference here was just that we had to add the color equals county. So each county would receive their different colors and different lines as well, instead of connecting both counties without the color equals county piece of code. All right, so we're getting towards the end here. Let's go to the next chunk. So now what I'm asking you to do here is plot the state total production on each year. So think about that, state total production. So we did already the average production over time, right? So we average over all counties and got the average county production over time. We did that, somewhere above. I'm not going to go to not get you all confused going back and forth, but we already did the average. Now what I'm asking you is, what was the total production in Georgia for a given year? Okay. So we're still gonna do here a group by. So we'll go ahead and add a pipe. Let's do a group by year. We're gonna connect that to a summarize. And I wanna call this total prod, this column, say equal. And now what like maybe if you don't think in functions, because maybe we haven't seen this function yet, but if you think about it, what is the difference between getting the average county production for a given year versus the total production in Georgia for a given year? What would be the operation that you do that differentiates those two concepts? Anyone has any thoughts?
Number of data in particular year.
But what do you do with that then?
We multiply the average with that number and we'll get the total.
Okay, that's one way to get there. Thanks, Shekar. What I want to show you is something simpler. So right now the data set has production per county, right, for a given year. If I want to, and those were all the counties that produce soybeans in that year. If I want the total production for that year in Georgia, I basically just sum all of them, right? So before we were taking the average because I wanted the average production. Now I want the total production, so we do sum. There's a function called sum. So it's very similar to what we did with the average or with the mean before. We just give the prod underscore million bushels, add a comma, and do not forget to do the na.rm equals true. Okay, so if we just run this, we now have the total production for each year in Georgia. And let's now plot it. So, it's going to be pretty similar to what we did already. So let's call it ggplot. We use the aesthetics function. We say x equals year, comma, y equals total prod, which is the column that we just created above. We go to the end of it, add a plus, and do geom line after that. Okay, so this is the total production in the state of Georgia for the counties that reported soybeans production, right? So we do see now here that this total prod is in million bushels, right? So now we see that around 1980, the state of Georgia was producing about maybe 35, 36 million bushels of soybeans in a given year, and that declined and then stabilized around maybe between 5 and 10 million bushels at the state level, right? And so one way as well for you to notice the difference is that the scale here is different, right? So now we're talking about like 30 million bushels, whereas before with the average, I think we were between like 0.5 and 1, right? Because that was the average per county, or sorry, the average per year, so averaging across counties, and now we actually added up all counties together. Okay, so now my last, the last plot that we're going to do today is basically to make, so this plot here, super cool. Let's say that that's what you needed for whatever it is. Like you had a project that you needed to report on the total production, and now we want to make this plot nice. We want to make it publication ready. So we're just basically, you can just go ahead, basically copy and paste the code on the chunk above. Just copy that and paste on the chunk below. And if you're running at this point, it's going to be exactly the same as the chunk above. But now I want to show you some ways that we can customize this and make it look nicer. And let's say if you wanted to have this as a part of a report or maybe a paper or a presentation, it would look nice. It's something that is aesthetically appealing and correct. Okay, so if you look at this plot right here, let me ask someone in Griffin, perhaps. What would be, if you can just tell me maybe one or two things that you would change about this plot to make it ready to be on a paper? What does it have to change?
The title of the picture.
Say that again.
Title.
The title. Okay. So that's
and the unit of production, like in mean bushel or in bushels, that's missing in the chart.
Yes, I like that. So the title is a good one, even though if you're thinking of like, normally on papers, we wouldn't have a title on the figure. Sometimes you do, but it's not super common. It's more something that would be at a caption level, right? So, but the axis titles for sure, we have to adjust them, right? So let's make them more publication ready. So if you come here after the geom line, add a plus. So ggplot has this function called labs for labels. And here it has the arguments X, Y, color, fill. It has a whole bunch of arguments that you can change, title, including title as well, subtitle. But one that we're going to change here is X. So first thing I want to, year here is lowercase. Y is lowercase. In a paper that would be, the Y would be uppercase. So let's first rename the X-axis to year, uppercase Y. So we can just say X equals year like that. If we just go ahead and run this, we see that result now that year is, properly named. Come back to the labs function, add a comma. You can hit return just to break the code. And let's rename that Y-axis. So we say Y equals open and close quotation marks. And let's call it, let's say state level production. And then you can open and close parentheses here and just say like million bushels. Okay, so if we do this and if we run it, let me just show you the code again. This is the output that we get. So it is looking nicer. So one thing that I want to change here, and maybe, this is not super important, but I still think it's a little bit, it could be helpful if we had more breaks on the x-axis. So now our breaks are 20 years apart. Let's say I wanted to have a break, or not a break, but a label. So like 1960 would be a label. I want to have a label every 10 years. We would come here at the end of the labs, add a plus, hit return. And ggplot has a function called scale underscore. There's a whole bunch of stuff there. We want to change the x-axis scale. So we do underscore x and then do underscore again continuous, because year is a continuous variable. So we're going to change that. And here inside, there's a whole bunch of arguments. The one that we want to change is the one called breaks, because we're going to define where the breaks will appear in this plot. I could come here and say, so what I'm going to do next, you don't have to do, but I could come here and say, I want to break at 1960, 1970, 1980, and so on. I could do this. It's a valid option, but it's not the most straightforward. It's not the most efficient way. So I want to show you, instead of doing this, there is a function called seq for sequence, like seq, that what we do is we say the starting value, the end value, and the increment that we want that to increase. So let's say our starting value could be 1960 based on the data. So that's the first argument. Our end value would be, we can say 2021, and then add a comma, and now I say what's the increment I want that to increase by. So if I want every 10 years, I just say 10 here. I'm gonna run this function like just by itself, so you see what it does. So if I just run that, this is what it gives me. It's basically 60, 70, 80, 90, so it's created a sequence for us, starting at the starting point, ending at the end point, and at the increment that we gave it. So we're basically this function is basically returning this sequence of numbers to the breaks function, just to automate things a little bit more for us. So if we go ahead and run that, make sure that you got your parentheses right. You want to have 2 parentheses after the 10, one to close the sequence and the other to close the scale X continuous. If we run that, now we have the breakpoints that we wanted. And now the last thing I want to do is just choose a different theme. So if I come here at a plus, the one that I'm proposing to do here is called theme underscore economist. That's the one I want to use. If you just run this, changes to that. And also one last thing I want to do here is I just want to change the color of this line to make it stand out more, because right now is the same color as the axis and the axis labels. I just want to change that to make it stand out more. I basically come to geom_line and I can say color equals, let's use blue. So just use a blue color here. All right, so this is our final plot. I'm gonna leave the code up there so you all can see what's going on. Any questions? Was everyone able to get to this point? If you were not, please let me know.
Professor, I have a question.
Yes.
Can we somehow add the values in the graph, like the highest peak? Can we somehow highlight that, like what the value at that peak is?
We can. We can do that. It's just that if we want to do that now, it's going to take some more time to do it, and I don't want to spend that time doing this. But we definitely can, and I can show you. I mean, we can go through this later if we have time, or if we can just talk on the side as well if you want to know how to do that. But it's definitely possible, and it's pretty straightforward as well.
That's what I wanted to know. All right, sure, we can work on that later. Thanks.
All right. Awesome. Okay, so so we finish with most of this right now. Since we were doing a lot of wrangling, so if you remember, we did some wrangling up here, right? So we did a whole bunch of stuff right here, meaning that the data that we're using was modified. We processed it. Let's also export to this data. So what I want to ask you to do is so outside of any chunk, right? So now we're just like in the script, so not inside of a chunk. Just add a hashtag, because if you're outside the chunk, the hashtag means heading 1. One hashtag is heading 1. So let's just say exporting, right? So hit return, create a new chunk. So we haven't, up until this point, you have not created chunks yourself. I just want to show you can just go on that C+ for a plus chunk symbol and just hit that. It's going to create a new chunk right below it. Okay, so again, that green C+ button creates a new chunk. And let's use the function write_CSV to export this data, this wrangle data. So the name of the object is soy_w, right? So that's the wrangled version. That's why it has a W in front of or at the end of it. You add a comma. Let's break the line here just to make it easier to see. Now we need to tell where to save this. So let's open and close parentheses. If you remember, if you have all of your projects set up correctly, so you have the NASS appearing there. If you click on the R blue button and it takes you to this main folder of the project, then you're well set up. So right now, this script is inside the code folder. We need to get outside of it. So to do that, we do // If you hit tab, you're going to see now what is at the level. So at the main level of the project, we go, let's go inside of the data folder. And now we give it the name of the file that we want to save. So I want to call this soybeans_NASS_processed.csv. So we have to give the extension of the file that we're exporting, right? So that's why we have to say .csv. That's how it knows what we're exporting. If you run this, and if it doesn't give you any errors, if you come here on the right panel on the Files tab, and you go inside data, you should now see the soybeans NASS processed. Now, this is going to be critical for us to do the next script, which we're going to do coming up now. So if you were not able to export soy.w as soybeans NASS processed on the data folder, let me know, because we will need that for the next exercise. Okay, I take that everyone was able to. If you were not,
Hold on 1 second, Doctor. So we've got one guy here that's trying to get the chart still. Give us just 1 second.
Oh, yeah, absolutely. So while you guys are catching up with the chart, I just want to tell you now one thing that I think is super cool. I found this super exciting when I found out, and now I want to expose you to that. So with our markdown files, which is not what we're using today, you can very easily create a report out of your script. With Quarto files, which is like the next generation of our markdowns and is what we're using today, we can also do that. And what I want to show you here is, so I have my script, and maybe you know something that is different from the markdown to the Quarto is that we have this render button right here. Now, if your code works perfectly, like if you were to come here and say run all, and it would have no errors, no mistakes on your code, everything's working fine, this should work seamlessly. So I mean, doesn't matter where you are in the script, if you just go and click render, it's gonna pop up a different window here. It's basically processing, doing some processing in the background. If you see the stop button, it's because it's working, so it's processing things. And then it creates an output right here on the side. I just want to show you my output and then open up if anyone has had issues rendering. But just check out how cool this is. So this is an HTML file that if you want, so the output of the rendering is an HTML file that if you open that, is going to open on your browser. So notice how all of our heading ones now have numbers here. I asked it to fold the code. The code that we did is folded. If you click on that, it's going to show the code, but you can hide it. And then every time that we created an output, so the output could be a table, could be a plot, is going to appear in this report right below the code. So the code is there. This is just printing it. And notice how it also created a table of contents for you right here on the side, using the number of hashtags as the heading level, right? So if it was one hashtag was a heading 1 level, if it was a 2 hashtags, it would be a level 2, so it would be indented in that. And if you I'm just going to scroll here, you know, this is all, you all did this as well along in class, right? We developed this script together. So see how now it's really, really cool. Like it has all the plots together. You know, it's very nicely formatted. If for some reason you want to see the code, you just go and unfold the code. But if you want to hide it, it's already hidden. And just how we are basically, you know, creating this cool report that you can share with anyone. You know, the person does not need to have R or Studio because now this is all in HTML format. So you can really share this with anyone if that's your goal. And this is one of the cool things about Quartal files is that you can go from a Quartal file to an HTML very nicely designed output very easily, right? So I want to come back here to RStudio, and I know that like for Quartal to be able to be rendered and create the HTML file, maybe there needs to be some packages installed. I think that by default they are already installed, but if they were not, maybe you got some error, especially on the background jobs. Maybe you got some error here, or maybe on your console saying that it was not able to render. So I just want to stop for a moment here and ask, was anyone not able to create this report?
I wasn't able to do it.
Was very
So
No, awesome.
in Athens, is that in Athens?
Yes, sir.
Okay. Was it
Griffin.
okay? So some people in Athens, some in Griffin weren't able to.
Yeah, even me, I got some problems.
Okay, it's probably some packages that need to be installed. So for right now, let's just pin that. But after class, please send me an email that I do want to make sure to troubleshoot that and make sure that you all can create this report. Because one of the cool things about this report is it is very nicely formatted without you having to do a lot more about it. But it's also like you can share it with a person, and a person does not need to know RStudio, does not have to have your data. It's already embedded into that HTML. So it's a very powerful way to share, like, especially things that you do in R with people that are not familiar with R. So yeah, after class, please send me an email and let's troubleshoot that. Because I do want all of you to be able to create this type of report. Okay, so, and I just want to quickly walk you through here something that we have not talked much about yet. So both on our Markdown, but also on Quartal files, there is this, every script starts with 3 dashes and it has some things within the dashes and then ends up with the 3 dashes again, and then it's where you start, your own programming. So this is called the, I never heard anyone saying, so I don't know if it's pronounced YAML or if it's YAML. So it's YAML is the name of the language that is being used up here. It basically defines some of the options. So for example, some of the things, and it's pretty straightforward as well, right? So the title that you give here as title appears on your output as title, the subtitle, again, as a subtitle. If the author is you or a person, you just say your name is going to appear there as author. And then I have some options here that I changed myself that I didn't ask you to do, it was already there. So I'm saying the code fold equals true. So I do want the code to appear, but to be folded, so hidden away. This embed resource is true. Make sure that if you send me the HTML, I can open it and everything is going to be there. So every resource used in that script was embedded in it. Talk is table of contents equals true. So it automatically creates that table of contents. And then I just define a theme here. So I define theme equals cerulean is one of the themes. There are like, I don't know, 20 or 30 different themes. I just want to show you here how quickly it would be for you to customize your theme of the report, right? So we're not talking about ggplot themes, but theme of the report. And there's one that I thought was very interesting. Let me see, I think it's the one called Vapor, perhaps. Let me just try that to Vapor. Here, I just had some options for you to, some of the most different options for you to see. So I changed that to Vapor, just gonna render again, and it's going to recreate my project, but now with a different theme. And I just want to show you how easily it is to do something like that. Yeah, so this is a pretty different one. So it has some different colors and, may not be a favorite, at least I don't think I would use it, but it's just a different option, just so you see how easy it is to create, different types of reports. All right, I want to close this report now. Come back to R. I just want to change again to the theme we had before, which is cerulean. Feel free, once, if you were able to render your project, feel free to play around with these different themes and see how they look like. You may come up with your own favorite. But I just also wanted to notice here, or to bring this up to you. If we come on the code, so I have more stuff than you do, and that's okay at this point. But I just wanted to point out how, so you have the 0 on 30 NASS summary partial, but you have the QMD. When you render and that creates the HTML file, that HTML file appears on the same folder where the QMD file is. So it is right here. You know, if I were to just click on this, it would again launch on the browser. So I just wanted to show you that file, that HTML file is right there as well with your code. Okay, so we finalized this part of the script, or this script. And if you notice, we did do a lot of stuff, a lot of exploratory data analysis, exploring the data, doing some different plots, but none of it was really geospatial, right? So the next thing I want to do is to do the geospatial exercise. So for that, I did upload last night some more files to the GitHub. So please go ahead on the GitHub and download that again. Download the entire repo again. So it would be the 2023 Advanced PA. And you would, again, download all files. So all the files using that code button, and just download zip. The new script that we're going to be working on the second hour today is called 0201 NASS spatial partial. So once you download the repo to your computer, make sure you copy and paste this QMD file from the GitHub repo that you downloaded and into the code folder of the 02 NASS project. Okay, I'm just gonna give a moment here, maybe a couple minutes, for you all to do that.
Which QMD file was it that we needed to make sure, the spatial partial one?
Yeah, so yeah, the spatial partial is the one that we're gonna be working on next.